Hi, everyone. Welcome to our next video for week 7 on correlation versus causation. So this is wrapping up our discussion about linear regression and correlation. So far, we've talked about tests for significance and finding that correlation coefficient, but we need to talk about how to interpret those results. So when we perform a test of significance and we find a significant linear relationship between X and Y in the population, any one of the following 5 possibilities can exist. It is possible that when there's a significant linear relationship between X and Y, there is a direct cause and effect relationship between these variables. That means that when X changes, it causes Y to change. So for example, in the last video, we saw an example where there was a linear correlation between the number of fires occurring and the number of acres burned. Well, we expect there's a cause and effect relationship. The more fires you have, the more area is going to get burned. The fires are causing the acres to be burned. Direct cause and effect. Also, it's possible there's a reverse cause and effect, meaning that Y is causing X to change, not the other way around. In both of these cases, a cause and effect relationship exists, and that's a reasonable conclusion. However, there's 3 other possibilities. It is possible that the changes that we are seeing in both X and Y are caused by a common third variable, meaning changes in X are not affecting Y, changes in Y are not affecting X. It's something outside the system we've looked at that is causing both of those things to change together. Another example is there may be a complexity of interrelationships among many variables, meaning more than just the 2 we've considered, that changes in X on some level affect Y, but there's other variables playing a role. This happens a lot in sociology, in psychology, sometimes even in medicine. Human beings are complicated. Natural systems can be complicated. So finding a direct cause and effect relationship may not happen very often because there's lots of variables and an interdependent relationship between them, resulting in that relationship we see in the hypothesis test. And then the last one is that relationship that we see in data could be completely coincidental, meaning there's no practical relationship between variable X and variable Y in the real world. They just coincidentally happen to change in the same direction together. The important thing here is that correlation, finding a significant relationship via a test of significance, does not imply causation. Just because X and Y change together does not mean that X causes Y or Y causes X. That is a dangerous assumption that is not always true. And a lot of unpracticed statisticians and non-statisticians make this assumption when they see correlation. They see 2 things change together and assume that one is causing the other. And that is often not the case. So as practicing statisticians, it's really important that we keep this rule in the back of our head when we're analyzing data. Just because we see 2 things change together does not mean there is a causal relationship there. For example, there is a positive correlation between the number of deaths per year caused by people falling into a pool and drowning and the number of movies that Nicolas Cage stars in. It is highly unlikely that Nicolas Cage is running around the US pushing people into their pools and causing them to drown. So this is an example of a completely coincidental relationship. But if we look at the number of people who drown by falling in pools and the number of movies that Nicolas Cage appeared in, those 2 variables change together. As the yellow line goes up, that purple line also tends to go up. As the yellow line goes down, the purple line tends to go down. We see peaks in the same place. We see valleys in the same place. But again, pretty sure that one of those things is not causing the other. This is an example of correlation without causation, and it occurs a lot. So make sure that you check your assumptions when you're analyzing data. As statisticians, it's important that we keep an open mind and that we look at that situation with potential biases in mind so that we don't commit any errors in our data analysis. We don't want to assume things that we don't know are true. Okay, so that was a short video, but important information. Again, if you have any questions about the correlation and regression process that we've talked about, feel free to get in touch via email or drop by my office hours. Otherwise, I'll see you in the next video.